Okay, so let's jump to problem number 8. So on problem number 8 on the homework. Now, let's look at what information they're giving us. They're giving us passing both exams. So let's label the exam. So A will be first exam. You pass the first exam. Okay, so we like A, right? It's a good thing. B is equal to you pass the second exam, so we also like B. Another good thing. Okay, now, if you pass both exams, what does that mean? That means that both are occurring, right? So that means probability of A and B is this number, in my case 23%, or 0.23 as a decimal, okay? Now, what is this information here? What information are they giving us here? Or what are they, actually this is easy. 51% of the class passed the first exam. So how would we write that in probability language? That's the probability of what? Which event? That you pass the first exam. That's A, right? So I know probability of A is 0.51. So now what are they asking me about? Okay, so they're asking me about this guy. What percent of those who pass the first exam also pass the second exam? So isn't that just A and B again? So isn't the answer just 0.23? And the answer is not quite. If you read this carefully, what percent of those who pass the first exam also pass the second exam? So who passed the first exam, that's a condition. That's already occurred. So if you've passed the first exam, what's the probability that you'll be also a person who passes the second exam? So passing the first exam is your condition. Passing the second exam is the event that happens after the condition has occurred. They're not saying pass both, okay? Because pass both, I know it sounds weird, but pass both could mean somehow you took the second exam and then later on you took the first exam, maybe you did a makeup on it or something. They're not saying what percent passed both. They're saying of those who passed the first exam, what percent of those people passed the second exam? So passing the first exam is your condition. And of those people, I want to know who passed the second test also. They're not saying who passed both out of the whole class. That's a different question. We already know that. The ones who passed both, 23%. Okay? So if I line up, so the 23% means if you take, line up everybody in the classroom. So here's the whole classroom. So here's the whole class. If you take the whole class, right, 23% of them, which would be about this many, out of the whole class, this many, 23%, passed both exams, right? So if you have if you say everybody who passed both exams go to the right side of the room, that would occupy about 23% of the classroom, right? This right here, this situation here is saying if you pass the first exam, so if I take the whole class, so this is the whole class, and I say, okay, if you pass the first exam, go to the, let's say, to the left side of the room if you pass the first exam. So I don't know how many that is, okay? Actually, we do, 51%, okay? 51% pass the first exam. So if you pass the first exam, let's say you go here. So everyone that passed the first exam, go to the right side of the room. Okay, so those passed the first exam. Right, that's 51% of the class. Of those, now if you pass the second exam, go, let's say, to the upper part of the classroom. Go up here, like above this line. This is what I'm looking for right here. Of the ones who passed the first exam, how many of you also passed the second exam? Okay? So first we're conditioning by passing. We're saying first, if you pass the first exam, that's my first condition. I'm throwing out everybody else. I don't care about them. And then of those, of the ones who passed the first exam, of those, which is this side of the classroom, how many also passed the second exam? That's different than saying everyone in the whole class, if you pass both, go to the right side of the classroom. That's a slightly different question. Okay? So it's a bit, you have to kind of get used to this reading a little bit. What percent of those who passed the first exam then pass the second exam? So to get into this situation, you first have to pass the first exam, and of those, what percent pass the second exam? Okay? So, since this is my condition, now passing the first exam is event A, right? That means I'm conditioning on event A. So that means after the conditioning bar is event A. And I want to know who also passed the second exam. So I want to know B given A. That's what I'm being asked for. I'm putting the conditioning event The event that happened first goes after the bar. Okay? So A is after the bar. Okay? Because A is my first exam. Passing the first exam is my conditioning event. Now, what do we know that that's equal to? We know that's equal to what? The probability that both occur at the same time divided by the probability that the conditioning event already occurred. The event after the conditioning bar. Okay, the event after the conditioning bar is what you're dividing by. Okay, now, which of these do I know? Do I know B given A? No, that's what I want to know, right? That's what I'm trying to find out. What is the probability of A and B? Do I know that? Yes. What is the probability of A? Do I know that? Yes. Okay, so I can just divide these. Okay, and if I divide them, I'm getting, let me grab my calculator here. Whoops, just dropped my calculator. I'm getting 0.45098. Now they want this in percent form. Okay, so in percent form, that would be what? 45.098%. Okay, they want percent form to 3 decimal places, which means you want to take your initial answer to 5 decimal places. So this guy should go to 5 decimals so that the percent can go to 3 decimals. Okay? So once again, what percent of those who passed the first also passed the second? That means who passed the first, we're assuming that's occurred. That means that's your condition. So that goes after the conditioning bar. And that means that's the event that you divide by when you do the conditional probability formula. Okay? And that's it. That's the key. All right, cool. Okay, so let's jump ahead to problem 9 here. And on problem 9, let's see. So what are we being asked for? First of all, let's label some events. So probability of, whoops, hang on a second. Okay, so probability of football, we'll just use F for football, and we'll use B for basketball, make life easy. Okay, so 22% of all students play football. So that means probability of F is 0.22. Okay. Whoops. Actually, I read that wrong, didn't I? Okay, it's not F. Football and basketball. Probability of F and B. Okay, got to read the whole sentence. Is 0.22. All right. What about the probability of football itself? That's 40%. Okay, and what are we being asked for? We're being asked for what is the probability that a student plays basketball given that the student plays football. So we should be familiar with how to write that as a conditional probability now. That's the probability of what? Basketball. Given that means condition, football. Okay, what's the formula for this? That both occur together, divided by the probability that the conditioning event has occurred. So what are we being asked for? We're being asked for this guy. So as long as I have this and this, I'm good. Do I have them? And the answer is yes, I do. Okay, so you should be able to complete this pretty quickly. All right, so I'll leave this up to you. Okay, and again, they want the answer in decimal form. Okay. Okay, so this is problem number 11. And in this case, let's kind of label our events here. So obviously a good label would be G for green marble. And we'll do R for red marble. Okay, so what they're asking for here is they want to know what is the probability that marble number 1 is red, okay, given that number 2 is green, or are they asking it the other way around? Is it the probability that number 2 is green given that number 1 is red? So which one is it? Okay, so which is the given information, what's already happened? And what's already happened is this. Okay, that's already occurred. So that's the conditioning event. That's already happened. If it's already occurred, if it's already happened, that means that's the conditioning event. That goes after the conditioning bar. So that's the condition. Okay? So that means this has already happened. So that means they're asking about this guy. Okay? Now, one way we can get this is to use the equation. What's the equation? The equation is the probability of, remember, for conditional probability, the probability that marble 2 is green, given that marble number 1 is red, would be what? The probability that both occur at the same time, divided by the probability that the conditioning event has occurred, which is that marble number 1 is red. The problem with this is it's difficult to compute. Now, probability that marble number 1 is red, that's easy. Okay, there's 24 red marbles out of 44 total. So this guy would be 24 ways that the red can happen out of 44. Easy. This is difficult. I'm not quite sure how to get the probability that marble number 2 is green and number 1 is red at the same time. I could think about that. But an easier way to go is use the direct method. Okay, just write out the sample space. What's the sample space going to look like? Sample space means the listing of all possible outcomes. So my listing of all possible outcomes here is going to look like this. It's just going to be, I'm going to have 20 green marbles, and I'm going to have 24 red marbles. That's my sample space. I could just write G, 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 G 20 times, and then red, 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 red 24 times, but I'll just kind of write it this way. I just think about 20 green marbles and 24 red marbles all lined up. That's your sample space. This is my initial sample space before I pull any marbles out. Okay, now what we're going to do is we're going to assume the first event occurs. Okay, so the first event occurs. What is the first event? The first event happens. What's the first event? The first event is if the first marble drawn is red. That means I pull a red marble. So I pull out a red marble. So what's my new sample space look like? Let's think about the new sample space now. The new sample space is going to still have 20 greens, but it's going to have 23 reds. All right? That's my new sample space. Okay, and again, sorry to kind of jumble the two. Let me kind of put a little line here just so you can see we're doing a different analysis. Whoops, down here. Okay, I'm just kind of separating off the two analyses. The top analysis is if I was trying to do things by an equation. The second analysis is if I'm just writing out the sample space. So essentially what we can do now is if we're using the sample space method, we can essentially just say, okay, what's the chances that the second marble is green in the reduced sample space? Now we're going to use the reduced sample space. Why? Because the first event's already happened. So we use the reduced sample space. So in this new sample space or reduced sample space, what's the chance of getting a green marble? Okay, and the chance of getting a green marble is going to be, well, probability of a green marble in this sample space is going to be, well, how many ways can a green occur? 20. Out of how many ways can anything occur? 43. Okay, and if I divide that, let's see what I get. 20 over 43, I'm getting 0.46511. Okay, which to 3 decimal places would be 0.465. Okay, so it's much easier if you can write out the sample space in situations like this, that all the different elements within the sample space. It's quite often easier to just sort of reduce the sample space by thinking about what happened in the first event and then compute the second event within that new or reduced sample space. Okay, that's going to be a much easier way to go on these kinds of problems. All right, cool. Whoops, and sorry about that little line there. My bad. Okay, so let's go to problem 12. And in problem 12, we're talking about, whoops, so actually we're not on problem 12. Hold on, let me move on. Okay, this is problem 12. Sorry about that. Okay, so we can try to do this using, again, this is a conditional, there's a given that, which means it's a conditional probability problem. Now, with conditional probability, we can typically do that using the equations method, or if possible, writing out the full sample space. In this case, both are going to be possible. Okay, so if we use the equation methods, what are they asking us for? They want the probability that a randomly selected student is male, given that they speak French. Okay, so let's label our events. Okay, so M would be male, Okay, I guess F would be, well, F is female, but F also is French. So I'll just use M complement for female. They're not asking about that, so I don't think we're going to need to use that. And then we'll use F for French, speaks French. Okay, just so it's easy to remember. Now, so the equation method, what are they asking us for? They want the probability that a randomly selected student is male, given that they speak French. Now, what equation do we know? The probability that both occur at the same time, divided by the probability that the conditioning event occurred, French. Do I know what the probability is for these? Well, how many people speak French? I've got 5 French speakers in the females, and I've got 1 French speaker in the males. So how many French speakers total? How many French speakers total? I've got 6 total French speakers out of a total of how many students in general? How many ways can I pick any student? 27 ways. There's 27 ways to pick any student, but only 6 ways to pick a French-speaking student. So number of ways the event can occur, speaking French, divided by number of ways anything can occur. Okay? Now, what about being male and speaking French? What's the probability of that? Okay? Well, how many ways can the event occur? How many people in the sample space are male and speak French? 1. How many ways can you pick anybody in the whole sample space? 27, right? So number of ways the event can occur, number of ways for male and French to occur at the same time, divided by number of ways for anything. Any outcome, meaning any person can be picked, right? This is number of ways for what? For French to speak French, and then this is number of ways for anything. Any outcome. Okay? That's how you compute probabilities. And we're dividing. Okay? So we're going to have 1/27th divided by 6/27ths. And of course, to divide by a fraction, we just multiply by the reciprocal. Right? Just flip that over and multiply, and we get what? 1/6. And if we convert that to a decimal, we should get the correct answer. Okay? As long as we round our decimal correctly. Now, can we also do this by reducing the sample space? And the answer is, yes, we can. Okay? If I just kind of write out my sample space, what's it going to look like? Well, let's put all my females together. So I've got, I'll tell you what, for female, let's just say W for woman. How about that? Sorry, I know it's kind of an older word, but we'll say W for woman, M for male, or man, and then so I'm going to have a woman, 1, 2, 3, 4, 5, 6, or in fact, let's do it this way. We've got 14 females, 5 who speak French, so I can just say, think of it this way. I've got of the 4, I've got 9 who don't speak French, right? So I'm going to say 9 are women but not French, do not speak French. And I've got another 5 are women who do speak French. Okay, 5 of them. And then how about the males? I've got 12 males who don't speak French. 12 people are males but not French, do not speak French. And then I've got 1 that's a male and speaks French. Okay, so it's kind of, it's just faster than writing out a whole bunch of letters. Okay, so that's just a listing of everything in my sample space. So given that the student speaks French, okay, so once we say given that the student speaks French, I immediately throw out the no French people. Gone. I've reduced my sample space. So this is my reduced sample space. Those guys together. Okay? Now, within that reduced sample space, what's the probability of getting a male? Well, how many people are in the reduced sample space? So in the reduced sample space, let me kind of change pen colors here. So in the reduced sample space, we've got 6 people total, right? And of the 6 people, 5 are, all of them speak French, 5 are women, 1 is a man. Okay? So within that reduced sample space, what's the probability of selecting a male? At this point, the French part's already been taken care of because given that the student speaks French means I've thrown away the non-French speaking people. They're gone. I have a reduced sample space. So now I just compute the probability of the event that's not the conditioning event. The conditioning event, this conditioning event right here, speaking French, that conditioning event reduces the sample space for me. So I throw away, in this case, I'm going to throw away the people who don't speak French. And now I just compute the probability of the other event, the main event, which is that the student is a male. The conditioning event has already been dealt with. Okay, so this is called the focal event and the conditioning event. Okay, so the focal event is male, the conditioning event is speaking French. Once I know this person speaks French, I can throw away the non-French speakers and just focus on the French speakers. And I have a reduced sample space. Within that reduced sample space, there's 6 people. What's the probability of this focal event happening, the male, person being a male? So the probability of male in this reduced sample space, how many ways can it happen? Well, there's 6 people in the sample space. One of them is a male, the other 5 are a female. So one way to get a male out of 6 ways to get anything, right? Easy. And we get the same result as we got using the equations. Yay! Okay. Yay means we're happy.